Good morning. Today is Monday, February 13th. So, two handouts. This one is some formula sheets. Please fill this out, and then you can make several copies and take it around your room. Okay? Make sure you are familiar with these formulas. They're very important for your first exam. Okay, everybody? Make sure you know it. And when is our exam? Next week, Wednesday. Today we will continue to finish 1.7, and then we will talk about 2.2. You see, we are already behind schedule. That is because we have so many things to cover in this course, right? And so, if you have questions, please feel free to ask me. And so you take notes during class. And after you get home, you review your notes. If there's some step you don't understand, please ask me, okay? Come to my office hours. Or if you're not available during my office hours, feel free to email me and then we can make an appointment. Okay, everybody? So try your best.
Practice exam, is it on Mobius?
No, the practice exam is on our course website at the very bottom. And then you see the practice exam and then the solution. And you also see exam 1 review session. Okay, so I want to ask you, when are you available? So you see, we are behind schedule. We don't have time to review in class. 15 minutes is really not a lot. The first 5 minutes, we talk about some announcement or something, and then then we only have like 45 minutes left every day. So we don't have enough time to do the review. So I'm happy to give you after school hours review session. Do you have time on Monday at 8 p.m.? So we're gonna do virtual, okay? So you don't need to come here in person. Let's do it virtual. Do you have time on Monday after 8 p.m.? If yes, please raise your hand. Monday review session, virtual review session, Monday after 8 p.m. Yes. Okay. So yeah. Okay. I will send you announcements. I will also make recordings. Okay. So so this week our exam covered chapter 1. So it's from all those prerequisite knowledge up to 1.7. Okay. So 2.2 and 2.3 are not on your exam, but we still need to cover it, right? We keep covering new things because you need time to study for the exams, right? In the meantime, we cover new topics. But just keep in mind, exam 1 only covers chapter 1, okay? And so please fill out this formula sheet and make sure you're familiar with those, and then do the practice exams. So at the very bottom of our course website, you can see the practice exams. And please do it multiple times. My student told me that, some of them told me that he did it 3 times. Okay? Maybe the first time he did it 1 week before the exam. And then the second time he did it 2 days before the exam. And then last time he did it 1 time, the night before the exam. So after you finish, you can click the solution. So click the solution and check your work. And make sure you check the details. You see, each step has points. Okay? If you make some mistake, and then take up some points. So unlike your homework you just check mark or write down the corrections. Your practice exam, you need to grade it and then estimate how many points you get on each problem, and then add them up to get the total score. Is that clear, everybody? The practice exam is 10 points. It is due on your exam 1 date, okay, the midnight. But I strongly recommend you to do it before that. Let me show you some data. This is my pre-calculus last semester. And exam 1, I would say only 1/3 of the class passed exam 1. And you can see, this is 70. All the students who get over 70, they did the practice exams. And then all the students who get lower than 44, they didn't do the practice exams. You can see how important of doing the practice exam. Because I ask you the same type of questions. Of course, the problem might be different, right? I change numbers, I change the functions, but usually the type of questions is similar. If you know the steps, then you follow the same steps and do the problems on your actual exam. Okay, that's why some students said it's very helpful to do the practice exam multiple times. And the first time when you finish, when you use red pen to grade your work, for the problems you get wrong, write down the correction and make sure you know the correct way how to solve those problems. Okay, if you get it wrong and you don't learn the correct way, then you just keep doing it wrong, right? We need to improve so we know our weakness. Okay, now we improve. What is the correct way? And usually for the problems that I teach you, I try to write down the steps, right? Like how to solve polynomial equation. Step 1, move all the terms to the left-hand side. Step 2, factor. Remember that? At every problem, I try to write down the steps. So when you see a new problem, okay, keep those steps in your mind, and then you work on the new problem. Okay? Yes. So this is how we learned. And so okay, yes. So please, this week, finish the practice exams and then look at the solution to grade your work. Okay, that's you do it the first time. Then Monday at 8 p.m. I will see you in the virtual class. So you know how to get to the virtual classroom? You go to our class and then click Tab Live. Like you did it in the snow day, right? You click this join course room and then you go there. Is that clear, everybody? Yes. And then at that day, the video session time, we will go over the practice exams and make sure you understand all of it. Okay. Right. Okay. All right. So last time we talked about how to solve inequality. And inequality involving absolute value. Absolute value is the distance between x and 0. If this is small, what? Move your hands up. This is small, inside. This is big, outside. What inside means? Between a and minus a. Right, everybody? What outside means? Less than minus a or greater than a. If you have equal, then you include the endpoint. Yes, everybody? So last time we did example, let's see, we do part A. Let's continue. And because we are behind schedule, so I'll let you to do part B at home. Let's look at part C. So this is exercise. Do it at home. And let's do part C. Okay, so we isolate. Okay, so isolate the absolute value term. Isolate means we only want to have that absolute value term by itself on one side, right? So what do? Subtract 2, exactly. So we subtract 2 on both sides. And then 3 absolute value of x minus 1 less than, what is 8 minus 2? 6. And then what do? Divided by 3. So when we work with inequality, be careful, right? If we multiply by or divided by a negative number, we need to flip the inequality. So, where's my attendance sheet? Is it here? Interesting. Okay. All right. Maybe I forget that in my office. Okay. Please just sign your name here at the back. Do you have another piece of paper? Do you have a piece of paper that I can borrow? Yes, out of notebook that works. Yes, thank you. Okay, so we divide it by 3. Okay, it won't change the inequality sign. What's 6 divided by 3? 2. Okay, tell me, this is small or big? This is small or big? Small. Then it's what? Inside. Inside. So it's between what number and what number? Between one number and one number? Exactly. So we put x minus 1 between -2 and 2. Okay? So we break the absolute value. It depends on whether it's inside or outside.
How do you determine the smaller big again?
Oh, the distance is smaller than the number. Small. If it's bigger than number, then big. Right. Yeah. Okay. So, how do we solve for x? Add 1. Yes. We add 1. -2 add 1 is -1. A 2 add 1? 3, right? Okay. So after we break the absolute value, we might get a compound inequality, right? And then we solve for x. Okay, and then graph it. Okay, graph the inequality and write down the interval notation. So here, -1 and 3. Open circle or solid circle at the endpoints? Open, right? It's between them. Then when you write down the interval notation, do you use parentheses or brackets? Brackets? Parentheses, right? Do we want to include the endpoint? Oh, do you have equal? If you don't have equal, that means you cannot include the endpoint. Yeah, if you have equal, that means you can include the endpoint. Then you put a solid
So
circle.
equal means brackets.
Yes.
Okay.
It's close.
Close.
Oh, close interval, right? Parentheses, open interval. Yeah. Okay, so -1 and 3 parentheses. And then we finish the problem. So far, so good, everybody? All good? All right. The practice, I will also let you to work at home. You know, math is really doing a lot of exercise, and then you get used to it. You see all these problems? We have seen some similar problems before, right? So you do those exercise. Make sure you remember the steps how to do it. Okay, any questions about 1.7? Good. So our exam 1 covered up to 1.7. Okay. Now let's look at 2.2. So 2.2 is going to be in exam 2. All right. A relation is a rule that assigns x values is the inputs to y values. Okay, so here we have a machine. It's called relation. And we have some inputs. And then we get some outputs. Okay, And inputs, we usually call it X. And output, we usually call them Y. Then the set of inputs, like the X values, is called the domain of the relation. So before sometimes you hear me say domain, right? Domain is the possible X value such that the expression makes sense, right? You can consider this is like the X, possible X values. Okay, and then the set of outputs, the Y values, is called the range of the relation. Okay? And then a function is a relation that assigns to each input value exactly one output value. Okay, so it's like, okay, I have one input and I only get one output. Yeah, this is a function. Can I have two input and we get one output? Can we do that? So we assign this input, this output. We assign this input also the same output. That's okay. The output can be the same. So this is still a function. Okay? So what is wrong for a function? Well, we cannot have one input and then we assign two outputs. No, that is not allowed. Okay, everybody? You can have 1 to 1 or more to 1, but you cannot have 1 to 4. Okay? Each input, you can only have one output. Okay, everybody? Mm-hmm. All right. Look at example 1. Consider the following relations and are they, okay, find the domain and range. Okay, so how about you guys answer my question? Let's take turns, okay? Hi. Look at the first table. Can you tell me what is the domain? Domain is the x values, right? The x values are 1, 2, 3, 4. Exactly. This is set notation, okay? Have you learned set before? We use these braces, okay, for the set. And the things inside are called elements. Elements do not repeat. Even though you see, oh, 3, we have 2 of the 3, but you only write down the 3 one time. You don't write it 2 times. Okay, the elements won't repeat. So that is the domain. How about the range? Range is the y values. What are your possible y values? Yeah, 1, 3, 5, 7, 9. So those are the possible y values. Right, everybody? Okay, how about part B? Next student. What is your domain? Yeah, 3, 4, 5, 6, 7. How about your range? Right. Yes, everybody? We just write down, okay, those are the possible x values. Those are the possible y values. So domain and range. Mm-hmm. Good. Part C, next student. What is your domain? Yeah, 0, 1, 2, 3, 4. How about your range? Just 4. See, we just put one number. We don't put the 4 5 times there. Okay? Just put 4 one time. Next student. What's your domain? Yes. And what's your range? 10, 20, 30, 40, 50. Exactly. Right, everybody? Okay. Now, Which one describe y as a function of x? Jackson. Okay, how about I ask you? Is this a function? Be careful. Yeah, the 3 has 2 outputs. Yes, so the 3 has 2 outputs. So A is not a function. Okay, everybody? Next. Is B a function?
Yes.
Yes. Very good. Every input will just have 1 output, right? Okay. Next student, is C a function?
Apparently it is.
Yes. Right, it is a function. Okay, so keep that in mind. 1 to 1 is okay. More to 1 is also okay. But 1 to more is not okay. So even though all of them map to 4, that is okay. This is like a constant function. Okay? You know, the horizontal line is actually a function, it's constant function. No matter what you put in, you will get the same constant. So it is a function. Okay, how about part D? Is this a function?
No.
No. The problem point is the number 8 get mapped to 2 outputs. Right, everybody? So, therefore, A and D are not functions. Okay, function notation. If x represents an input of a function f, then the corresponding output is written as f of x. Questions?
What if for A,
Mm-hmm.
3, and then we go 5, 5, would that be a function?
Oh, if it's a 3, 3, and 5, 5, then you don't put the 3, 5. You don't write it 2 times because it means the same thing. So this is a table. Usually, we can like do a function or relation mapping. Then the relation mapping is like one. You have 1, 2, 1, 2, 3, 4 here, and then 1, 3, 5, 7, 9 there. You get 1 map to 1, 2 map to 3, 3 map to 5 and 7, and 4 map to 9. This is a relation mapping. And from this mapping, you see 3 is mapping to 2 outputs. Then we know, oh, this is not a function. Mm-hmm. Yeah. 1 map to 1, then in the table, you just write it 1 time, you don't write it 2 times. Mm-hmm. Yeah. Good questions. Okay, so we say f of x. So this is not f multiplied by x. Okay, everybody? This is not multiplication. This is function, and then we get the input x, we plug in the x, and then we get the output. Okay, so look at example 2. Here, f of x, okay? The input is x, and the output is the expression 3 minus x squared. Okay, everybody? So this is f of x. We want to find what is f of 2, f of 0, and f of minus 2. F of 2. Okay. F of 2 means whenever you see x, plug in x is 2. Okay, everybody? So let's see. 3, we write it down. Minus x squared. X is 2 squared. Right, everybody? What is 2 squared? 4. 3 minus 4 is negative 1. Right, everybody? This is f of 2. How about f of 0? We plug in x is 0. Right? Next student, what do we get? Exactly. 3 minus 0 squared is 3. How about f of negative 2? Okay, let me ask you. I put 3 minus -2 square. Am I right? What do I mean? Parentheses. So parentheses is like your baby. Don't forget your baby in the mom. Okay. So parentheses. Now what is -2 squared? 4. Oh, see, the negative square becomes positive. So 3 minus 4 is still -1. If I forget my parentheses, I get minus becomes plus. It becomes 3 plus 4, which is 7. See, that I will get it wrong. So be careful. Parentheses, very, very important. Okay, let's keep going. What is f of 10? We plug in x is 10, right? Okay, next student. What do you put on the numerator? Yes. Denominator? Yes. What is 10 plus 12? Yeah, 22. How about 9 minus 10? Oh, this is -22. Right, everybody? Okay, how about f of 9? Excellent, yeah. What did we just put on the top? 9 plus 12. How about the denominator? What is 9 plus 12? 21, right? What's 9 minus 9? 0. Questions. Can we have 0 in the denominator? No. Oh, therefore this is not defined. Okay. F of 9 is not defined. We cannot have 0 in the denominator. So that's why here, the domain. So when we find the domain, okay, we have rational functions. So this is called rational function, right? You have like fractions, right? Domain, we need the denominator not equal to 0. Denominator not equal to 0. Therefore, you set 9 minus x, that is our denominator. It cannot be 0. And then we add x on both sides. We get 9 cannot be x. So that is the domain. X cannot be 9. Therefore, if we plug in 9, that's not defined because 9 is not in the domain. Okay. So far, so good, everybody? Okay, so we plug in numbers. How about we plug in expressions? How do we do when we plug in expressions? We kind of erase x and replace by minus x, right? And when you replace, it has the minus. You gotta be careful. You need to include your baby parentheses. Yes, baby parentheses. So f of minus x is, you see, x squared. X squared becomes what? Negative x parentheses squared. Minus 3 times, you see the x? Replace it with negative x. Bless you. Can you tell me what is negative square? Negative square? Just x. Yes. It becomes x squared. And then minus negative becomes plus 3x. Exactly. So this is simplifying. You plug in it and then simplify. Okay. How about f of a squared? Well, whenever we see x, replace replace x by a squared. So we have a squared, yes. And minus 3x. Replace x by a squared. What is a squared square? A to the 4, right? Minus 3a squared. Okay. And then how about f of x plus h? Well, you replace x by x plus h, and don't forget the parentheses. Parentheses is so important. Parentheses x plus h. Replace x by x plus h. Okay, everybody? Typical mistake. What is f of x plus h? Well, this is f of x is x squared minus 3x, and then you just add h. Do you see? They are different. So whether your plus h is inside the parentheses or outside the parentheses, they are different things. So where your parentheses is, very important. Okay, everybody? All right. Okay. So continue. Example 5. Determine if each equation represents a function y equals f of x. All right. The first one. So we want to see whether one input x gives us one output y. Okay, everybody? Look at the first one. No matter what the x is, we only have one output. Right, everybody? So, yes, this is a function. Okay? So, we only get one output for each x. Okay. Part B. What would be the problem? Well, you want to solve for y. But when you solve for y, you want to get rid of the square. Right? So, you would take square root on both sides. But do you remember when you take square root, you get what? Plus or minus. Yes. So when you solve for y, you get plus or minus square root of x. Do you have, so I give you an x value, do you have one input? No, you have two outputs, right? So if x is 0, you get one output, which is 0. But if x is greater than 0, then you get two outputs. Right, everybody? So this is not a function. So no, this is not a function. How about part C? When you solve for y, what happened? Yes, we get keywords. And you know, keyword is one, output. Okay, so yes. How about absolute value of x? Okay, what's the difference here? The difference between here and here, this is one input that gives you two outputs, right? But this is actually two input give you the same output. So you still have one output, right? Okay, think about it. I plug in 2 and I plug in -2. They both map to 2. But you still have one output, right, for each number I plug in. So this is yes. So this is yes. And I can draw the picture to you. Okay, so this is the XY coordinates. You know how to put the points, right? We know when this is the X, this is the Y. When X is 0, absolute value of 0 is 0. When X is 1, absolute value of 1 is 1. And X is -1. Absolute value of -1 is also 1. So actually you get a V shape. But do you see every input? I got one output. We might have different inputs at the same output, but it's still one. Okay, everybody? So this is yes. This is 1 to 2. This is 2 to 1. 2 to 1 is a function. 1 to 2 is not a function. Okay, everybody? Yes. Example 6. Find the domain of each of the following functions. Okay, keep that in mind. When the problem asks you to find the domain, two things you check. First thing, do you see square roots? If yes, then you need the things inside the square root to be greater or equal to 0. Right, everybody? Because if you have square root of negative number, it's not a real solution. It's complex number. Right, everybody? Therefore, we need the things inside the square root to be greater or equal to 0. So if we have fractions, what do we need for the denominator? Denominator cannot be 0, right? Do we care about the numerator? Do we have restrictions on the numerator? No. Numerator can be whatever you like, but the denominator cannot be 0. Okay, look at part A. Do we have square roots? No, we don't have square roots, right? Do we have fractions? Yes. Then we need the denominator. Cannot be 0. Right, everybody? Okay, and now, how do we solve inequality? To solve inequality, we move things to the left and then we factor. How can you factor x squared minus 9? Very good. X plus 3, x minus 3. Yes. And then, because this is not equal to 0, we put x plus 3 is not equal to 0. And x minus 3 is not equal to 0. So x not equal to -3 and x not equal to 3, right? Okay, how do we use interval notation? Draw the real number line. -3 and 3. It cannot be through -3. It cannot be 3. You put open circle there, right, everybody? But otherwise, we can pick those points. So therefore, the interval notation, you get -infinity up to -3, parentheses, union, parentheses, -3 to 3, parentheses, union, 3 to infinity. So far, so good, everybody? Yes, this is how we use interval notation. Right. Okay. All right. Part B. Do you see square roots? Do you see square roots for part B? Yes. Then we need the things inside the square root, which is 2x minus 6. The things inside the square roots, we need it to be what? Greater than or equal to 0. Yes. So keep that in your mind. This is very important. Okay, solve for x. What do we do? We add 6 over. So we get 2x greater or equal to 6. And then what do we do? Divided by 2. Okay, so we get x greater than or equal to 3. Right, everybody? Okay, so let's draw a picture. 3 is here. Greater than or equal to solid circle because it has equal. Then you tell me, is it the left side or the right side? Right side, exactly. And interval notation. 3 brackets or parentheses? Brackets to infinity. Right, everybody? Yes? Okay, good. Now keep going. We increase the difficulty. See, this problem, we have square roots and we also have fractions. Right, everybody? Look at the square roots. Look at the square roots. We get what? The things inside the square root need to be greater than or equal to 0. Right, everybody? Yeah? Look at the square root. We get the things inside the square root to be greater or equal to 0. But look at the fractions. See? We have the x squared minus 9 is in the denominator. See? It's in the denominator. So it cannot be 0. It's greater than or equal to 0. It cannot be 0. When you combine them, we only get greater than 0. Right, everybody? Okay, how to solve inequality? Well, move all terms to the left, then factor. Okay, let me write down the steps. Move all terms to the left-hand side, and then factor. So we can factor it as x plus 3 and x minus 3, right, everybody? Okay, now what do we do is find the critical number. So, which means we set each factor equal to 0. So, critical number in this case, we set x plus 3 is 0 and x minus 3 is 0. What is x? Negative 3. And what is x? 3. Okay, very good. Then on the real number line, we plot those points. Okay? And look at the inequality. If you see less than or greater than, you put open circle on those points. If you see less than or greater than, this is greater than or equal, less than or equal, then you put the solid dot on that point. Therefore, here, the real number line, negative 3 and 3, do we put open circle or solid circle? Open. Open. Right, everybody? Yeah, this is something new because in section 1.7, the inequality we learned, they're linear inequality. You don't have x squared. But if you have x squared here, this is how you do it. Move all the terms on one side. Factor. Find the critical numbers. Plot those on the real number line. Do you see the real number line get separated into 3 pieces? Yes. On each piece, find a test point. Okay, so therefore, find test point. See if it's positive or negative. Okay, give me a number less than negative 3. What? Negative 4, right? You plug in. So plug in. Let me call this thing. What do you want to call it? Can we call it M? Okay, you plug in negative 4. What's negative 4 plus 3? Negative 1. What is negative 4 minus 3? Negative 7. Negative 1 times negative 7. What's that? 7. And it's positive. Right, everybody? Okay. Can you give me a number between negative 3 and 3? 0. And then what is your expression? 0 plus 3 is 3. Right? 0 plus 3 is 3. 0 minus 3, negative 3, right? You get negative, right? So it's negative on this piece. How about the last piece? What number do you pick? 4. Okay. What's your M? 4 plus 3? 7. 4 minus 3? 1. Oh, do you see this is positive? And we are looking for what? Positive or negative? Positive. Greater than 0. Positive. So we peg this piece and this piece. Therefore, we get minus infinity to negative 3. Do we include the endpoints? Do we include the endpoints? No. So parentheses. And then union. The other piece is from 3 to infinity. Okay, so let me finish. 6-1. Write the interval notation. Interval notation. Okay. Okay, so here are the 6 steps. When you have inequality with 3 greater than 1. Is that clear, everybody? In session 1.8, we'll talk about more of this. And I will teach you another easier method. This test point method is not easy. It only works for very simple problems. For harder problems, think about it. If you have 5 critical numbers, you separate it into 6 intervals, then you have a lot of numbers to calculate. It is so complicated. But we have another simple method. It makes the solution process much faster. So we talk about in session 1.8, and my plan. Okay. Where is it? Okay. So we will cover 1.8 after we finish 3.2. Okay. So later. All right. And then next topic, piecewise function. Have you seen piecewise function before? Raise your hand if you saw piecewise function before. Okay. What does that mean? So these are the different x values. And it says if x is less than or equal to -1, we're using this expression. If x is between -1 and 4, we're using this expression. If x is greater than 4, we're using this expression. So it's like we have the real number line. We cut it into 3 pieces. See, the first piece is less than or equal to 1. That is the first piece. Right, everybody? A second piece is between 1 and 4. And we don't include a 1, we include a 4. So this is the second piece. And then the last piece, right, greater than 4. This is the last piece we use this expression. So this is a piecewise function. Okay? So it depends on where the x is. Okay. How about, you tell me, -2, which piece? 1, 2, 3. -2 is in the first piece. So we plug in the first expression, right? Okay. Maybe let's continue on Wednesday. Okay. Yes. So keep this in mind. We continue on Wednesday. Have a nice day.